for sec.
What's the question for 3?
You said chapter 4, section 3.
Yes, that's what we're doing with complements.
I mean the question. We don't have the question.
Do you have a question?
Yes, I don't have the question.
You don't have a question.
You didn't upload it. Oh, the PowerPoint rather, the handout.
Oh yeah. I will upload. I will send those after as soon as class is over. I'll send them out to you.
Okay.
Yeah, because these were all getting ready for you all last week, but the printer and the whole network was screwed up. My computers were screwed up. Literally, my computer died. It wouldn't recharge, and the room computer kept on resetting itself every 5 minutes. Okay, we talked about complements already. What is a complement?
Are you recording?
Yes.
Okay.
Like, if we had a probability of A, the complement would be not A. So the formula for it is 1 minus the probability of A. So those are pretty straightforward. If I asked you if the probability of none, what is the complement of none? That's what you think. That's what you think. That's what people think. The complement of none is not all. It's at least 1. Because remember, we have to add, if we add up, if this was P of A, that means this is the complement of it. Together, both of these have to equal, when we add them, it has to equal 1. Or the total set. If there's nothing there, that means there's at least 1, or all of them. Because all is included in is at least 1. So let's look at some examples here. Or the probability of at least 1. What's the complement of it? Not again, no. Because if at least 1, the complement of this thing would be the probability of actually, this is be too confusing. But yeah, let's just stick with that right now. Because I'm going through all the different possibilities. So they're inverses of each other. So the complement of at least 1 is none. The complement of none is at least 1. Let's look at example 1. Manufacturing. A factory of the global manufacturing company was manufacturing products with a deficit rate of 15%. Deficit rate of 15%. If a customer purchased 12 of the products, what is the probability of getting at least 1 that is defective? Okay, customer bought 12. The probability of getting at least 1 that is defective. So here's our solution. The first thing we have to do is, what is A? Let's define what our A, B, A and A not are. So what we're looking for is the probability of getting at least one that is defective. So at least one of the 12 is defective. Let's find the complement of that. What's the complement of that? No defects. Now we got to calculate it. Remember, the defect rate of each one is 0.15. What is, if the defect rate is 15%, what is the non-defect rate? 85%.
85%.
So that's what we're looking here. The probability of a not defective is 85%, or 0.85. So for our example, we're saying that all 12 are not defective. So that's the probability of not A times probability of not A. Do that 12 times. Multiply the probability of not A, the 85%. So this is 0.85 times 0.85 times 0.85 times 0.85, which is 0.85 to the 12th power. And that one equals 0.142. Well, in this one, because we had multiple events, the complement, that's very, very good question, because our complement is of each individual event. Since it said that the defect rate of each element is 15%, we're looking at what is the non-defect rate of each element. That's 85%. But since with each one of those, and we happen all 12 of them are not defective, then we do the 0.85 12 times. Very good question. Yes. So it's not always multiplication. It just happens in this case, since we're dealing with multiple events, 12 of them, that's when we multiply them 12 times. So the last thing we got to do now is figure out, because remember, it says find, it said, if a customer person, what is the probability of getting at least one that is defective? Remember, this one is all 12 being not defective, is the 0.142. So what we're looking for here is the one minus the probability of not being defective. 1 minus 0.142 is 0.858. Or 85.8%. Because remember, we just calculated the 0.85 times 0.85. That's all 12 of them being not defective. What the question asks is, what's the probability of getting at least one of them that's defective? Or the probability of getting one of them that's defective. So what we have to do here is take one, which is 100%, minus all of them not being defective. Whatever's left over is at least one of them being defective. Let's go back to the drug.
Excuse me, sir, if you say one of them being defective, is 85.8% not too much for just one?
Actually, it's a very high. I wouldn't want something that's 15% defective. Normally, you're looking at 0.5 or 0.05% defective. Because I mean, if a company's letting him go through at 15% defective, it means out of every 100, 15 of them are broken. So they're really wasting their money there. I'd find another company. So but it just said for each one that's not defective, it's 85% chance. Okay, let's go back to our drug employment testing. This is example 2. It is asking if one of the 555 test subjects randomly selected, find the probability that the subject had a positive test result given that the subject uses drugs. That is, find the okay. Notice the optimal word there was given. So it says, find the probability that the subject had a positive test result given the subject uses drugs. This vertical line here in the probability, whenever you use the word given, because what that means, it tells us that we look at the probability of a test subject being positive only if the person uses drugs in this case. So we're looking for this first probability, the positive test result, given that the person uses drugs occurs first. So with that one, remember we had the 45 positive test results and the 5 of them were false positives. So we had, where is that data set? There it is. This data set. We're only looking at people who use drugs. Why do we use that? Because we're only looking for this set here. They use drugs.
Use drugs.
So how many of them were positive?
45.
45 over 50. Because we had the 45 that said yes, the positive test, and no, that they didn't use drugs. It was a false negative. So the probability that the test result is positive, given that they're drug users, is 45 over 50. And we did that one earlier, it's 0.900 or 90%. Question 2. If one of the 555 test subjects is randomly selected, find the probability that the subject uses drugs given that he or she had a positive test result. So we're looking at here, it said, again, it's find the probability that the subject uses drugs given that he or she had a positive test result. So we look at we first have to have a positive test result, which was a 70, which is 45 and 25. That was 70. And then now we're looking at the subject uses drugs. And there's 45 of those. Right? So that's just 45 over 70. There's 45 people who should use drugs out of a total of 70 that positively tested drugs. Remember, there were some other people who tested positive even though they didn't use it. So there were false positives.
Mister, what's the meaning of false positive on the other one?
What's that?
What do you mean by false positive?
A false positive, if you're looking for people who use drugs, sometimes the test will show that you, even though you never use drugs, the test itself, some anomaly somewhere that will make it turn positive. They have the same thing with pregnancy tests. It's called a false positive when somebody who takes a pregnancy test turns out to be positive, even though they're not. That's what a false positive is.
Okay.
It's simply an anomaly with the machine.
Okay.
We have 10 minutes left. We can do this. We can do this. Let's look at this one. Confusion of the inverse. The probability of A given B, probability of B given A. These do not equal each other. So as we're saying that the probability of event A occurring given that B occurs is not the same as saying the probability of B occurs given that A occurs first. So the A occurring given that B occurs is not the same as B occurring given A occurs. Like the example they use here is let A, it's dark outside, and B is midnight. So the probability of A given B as opposed to the probability of B given A. The probability of A given B. So the probability it's dark outside given that it's midnight. Is that a true statement? Yeah,
Dark
that's true.
outside. It's true.
Because it is dark at midnight. Or you can say that, can we say that the probability of it midnight given it's dark outside? No. Actually, we had that when we had the eclipse. The whole earth went dark, or at least for us, even though it was 3 o'clock in the afternoon. So it's very, very important that you, when you read these things, is whatever's after this vertical line, the given statement, that has to occur first. Example 4. Interpreting medical test results. Assume that cancer has a 1% prevalence rate, which means that 1% of the population has cancer, denoting the event of having cancer by C. And we have the probability of C is 0.01 for a subject randomly selected. Okay, the results. This result is included in the following performance characteristics of a test for cancer. 1. False positive rate is 10%. Rate equals 10%. Or the probability of a false positive equals 0.1. The true positive rate is 80%. Is 80%. 0.8. Find the probability of having cancer given that a positive test result. So find the probability of cancer given the positive test results. What does that mean? How do we figure this out?
After having a test, what's the probability of having positive results of cancer? So the test has to occur first.
Can we put this into a chart first?
Sorry?
Like we did earlier, have false positives and negatives.
Okay.
Well, let's see what we have here. So we have the positive test results, negative test results, and our totals. Those, the positive tests and negative tests are along the top of our chart. On the vertical, we have cancer and no cancer. So the positive test results of cancer, these are the true results. And the negative test, if somebody has cancer, is the false result, false positive, or false negative. Positive test and they don't have cancer, this is our false positive. And negative tests and negative, that's true. So the positive test results so the probability of cancer, of getting a true cancer reading is 0.1. 0.01. False positive rate is 10%. So we're going to say it's 100. We have a total of 100. So the false positive rate is 10%. So 10% of 100 is 10. And true positive rate is 80%. So that is 80. So the cancer given a positive test rating person has cancer given they have a positive test result. So it's 80 over
100.
So what would our negative be?
So the first negative should be 20% to make up 100. .
20% No, the sum of these has to equal 100.
Oh, okay.
This is going to give us 90, so this has to equal 10. So the true no cancer
0.
Let me see, do we have a false negative? We have a false positive. Didn't give us any false. This has to equal 100, that has to equal 100. False negative. True positive. So it's a 10%. No cancer is 1%. False positive rate is 10. Cancer percent is 1%. That's true cancer. The true positive rate is 80% of that. The false positive would be 10% of that. So the converse of this so false positive 10%, false negative is 80%. So also tell us. If we have 1%, so that means now we're dealing with 99 people. Out of 100. So it tells us that cancer is 1%. Okay, we had 1% of true cancer, so now we're looking at 99. So false negative. This is what we're looking for. We're looking for the probability of C given that positive test, which means the probability of cancer times the probability of a positive test given that it's cancer over the probability of cancer times the probability of positive test given that it's cancer plus the converse of that. The probability of no cancer probability of positive tests given that no cancer. That's the formula we have to do. Or in math terms, in general, we have the probability of A times probability B given A, probability of A times the probability of B given A, plus probability of not A times probability of B given not A. That's our formula for. Now we have to figure out what this one is. So we have the top set up already. It's 80 times 10 is 80. Now it's the bottom part I got to figure out. So it's going to be 80. And its probability is 0.8 times, because we're dealing with probability, so it's 0.8 times 0.1. Then this one's going to be 0.8 times 0.1 plus 0.2 times 0.9. That's going to give us the percent. That's why we just did this, and if I did it in percentages instead of numbers. So it's going to equal our probability of cancer given its positive test result is equal going to be 0.8 times 0.1, 0.8 times 0.1 plus 0.2 times 0.9. Because it makes up for these equal 100%. So it's going to be, final answer is going to be on top. We're going to have 0.8 times 0.1 divided by 0.8 times 0.1 got that. So on top we have 0.8 times 0.1 divided by open 0.8 times 0.1 close plus 0.2 times 0.9. There. The probability is 0.3077, 30.8% probability. For our example. That's yeah. All right, so that's that section. This is the formula itself was what information given. I wasn't reading it correctly. That's that. All right, everybody. That does it for chapter 4. We are now going to start